This is a Windows VM. No games, no Adobe Suite, nothing exotic, just Microsoft Office, a note-keeping app, documents, and a web browser. But it is quietly eating its way to almost 100 gigabytes. Seem familiar to you? This episode isn't just about freeing up space. It's about understanding why Windows can get bloated very quickly, and also what a surgical cleanup actually looks like. I originally found this on my main desktop, which runs a debloated, optimized image of Windows 11. So when it was initially installed, had a very small footprint. And roughly after a year, I was looking at 107 gigs of used storage on the C drive. And much like the example we're going to use today, there's no big applications, no game directories, nothing that you would imagine would take up that much space. And so when I originally investigated this, I was expecting, maybe a log file or something was going to be causing this, and it actually wasn't. It was Windows, but more specifically, it was one folder called WinSxS, which is to do with Windows components, and obviously we can't just hit delete and free up that space. And so that's what this video is about today. It's about the investigation. It's about understanding what we're looking at, and it's about making good decisions on the space that we free up. So here we are back on that Windows 11 VM that we'll be using for the example today. Microsoft Office Suite, Obsidian Notebook, and Edge. I've installed TreeSize free so we can do this analysis. Now I won't be using TreeSize free to remove any of the files, but we are going to use it to visualize where all the data is stored. Now when you open it, this is the UI, and we do have an option here that says start TreeSize free as administrator. Now we're going to do this, so we'll click that, then accept the UAC prompt. And the reason for that is if we don't run it as an administrator, we're going to miss files that the user level doesn't have permission to access. And so we want to see everything, right? So I'm going to select directory, choose local disk C, and it's now going to do its scan. It's a really cool app because it's very visual, and it's a descending order from most storage to least storage. So it's very, very quick and easy application to use to see where all your data is stored. And incidentally, I first found out about this when I was on help desk, and it's an absolutely fantastic tool. Low resources needed, the place I was at, we used it on a few of the Windows servers that were running applications that were very sensitive to how much available storage was on them. A few times a year, you'd see this server. We'd get some alerts for limited storage space when it gets below that 5% on the storage for the server. We'd get some alerts and have to take a look at it. And so yeah, long story short, really, really useful app. Okay, so when I had this originally with the desktop, I didn't have the windows.old folder, but there was this example here where it's got 31.5 gigabytes for Windows. If we expand that, top of the list, here's our main culprit, WinSxS. And again, we can't just delete this folder. It does contain old component versions, superseded update packages, metadata. It's a very important folder. There are Windows components that are currently being used, but there are, as we'll find out, files in here which we don't need anymore, and we can remove them to free up some of that space. Now, the windows.old is a slightly different example. Now, when you go through the process of updating Windows, and if it is a major update that occurs, it will create a windows.old folder. And what that contains is essentially a recovery image for where your Windows install was at the time you did the update. And this is quite a cool feature, actually, in terms of redundancy. If you have a problem with a new update, which does happen from time to time, you can roll back quite quickly. This kind of speeds up that process. As you can see here in the backup folder, windows.old, again, the top culprit under the Windows parent folder is WinSxS. So let's look at how we analyze it and make some decisions on how to then remove the unwanted data. So let's look at a couple of ways that we can do this. So we can go to Settings, go to System, go to Storage, click Yes. I'll just get that in here, expand it a little bit. All right, so we can see there's a temporary files. Storage Sense is currently on, and so we would assume that it would be looking after this automatically for us, but it's not. So what we have to do is something a little bit more specific. So let's look at cleanup recommendations. Let's take a bit of time to scan. As you can see, when we're looking at large or unused files in the cleanup recommendations, the paths we're being given it's all in the downloads folder, which are user files, right? We've also got previous Windows installations, 28.9 gigs. Interestingly, I think that might be linked to this windows.old folder. Downloads got 1.44 gigabytes there. Unused apps, and obviously these aren't going to be something that we need to look at, but there's an example of using the main settings, which, as you can see, there is an amount of space we can free up using this, but there is a better way. So we're going to get rid of that. We could also run disk cleanup, which is fairly standard way of doing it, which essentially is going to do what that other settings gave us the option for. This one hasn't seen the previous versions of Windows, which will be in that windows.old folder. So at least we did get that option with the main settings there. But if we were to click all of these options down here, we would have 1.12, we'd have just over a gigabyte, sort of 1.15 maybe altogether. So let's consider that, but let's look at a better option. We're going to open up the terminal, and we're going to open a command prompt, but we need to run this as administrator, because what we're going to use is DISM, which, let me look at my notes, stands for Deployment Image Servicing and Management Tool. You think I'd know that off by heart, wouldn't you? But no, I don't. I have to look it up. But I do know what DISM is, and we do use it. So first command we're going to do, and I am going to cut and paste this because it makes it a little bit easier, is DISM online, which means we're going to run it now while the disk is online being used. Cleanup image, which is module of DISM. It's well named in it, clean up the image. And the flag that we're using here is analyzecomponentstore. Now, obviously, this refers directly to that particular folder. So we're going to hit return. And I love a good loading bar. It's great. This gives us the information on the component store, that WinSxS folder. As you can see, it says Windows Explorer reports the component store is 20.83 gigabytes. The actual size of the component store is 19.36 gigabytes. This difference is probably has something to do with like the hard links that are used, pointing to the storage of where these components actually are, rather than, because they're not always in the folder, for example. So let's grab another command. I can do this one. We're going to use fsutil. And this is, we're going to see the hard links for just an example, just so you can see that this one has two hard links. One is in the component folder, and the other one is in the Windows System 32 folder. At the end of the day, they're just, there might be two hard links, but they're pointing to the same piece of information. Now, these are the bits of information here, break down what that 19.36 gigs is made up with. Some of it's shared with Windows, some of it is backups and disabled features, and some of it is cache and temporary data. The last cleanup was done on the 8th of the 4th, 2026 at 1:20 in the afternoon. Yeah, interesting. That might have happened as part of, I did run an update. I ran Windows Update yesterday, so that it might have had a sort of a post-update cleanup. Educated guess on that one. So number of reclaimable packages, 6. Component store cleanup recommended, yes. Now this is really important for you to take notice of. So this, running this command, listen to it. If it says no, listen to it. It means that the files that are there, the links that are there, the components that are there, metadata, everything is needed currently. And if you remove them, there's potential for you to brick your operating system. So definitely listen to that. But in this case, this is exciting because it says we can do that. Right, now let's look at the next command. Cleanup image is the module, and start component cleanup is the flag that we're using. That's the command we want to run because we want to do a component cleanup. Now, another flag we can use that's incredibly powerful, but has to be used very judiciously, and that is ResetBase. ResetBase is essentially the nuclear version of this. What you are doing when you use ResetBase is you are removing absolutely every superseded component within that folder. Now what this means is when you do your next update, there is no rollback path for you. You are essentially saying that you accept the current state of the image as it is. You are not going to be able to roll back an update. You can't uninstall an update. This is it. This is like you're drawing your line in the sand. It will remove significantly more data, but there's no real get out of jail option with this. So it's you've got to make sure that you're very aware of what you're doing when you use this particular flag. You know, in a home lab environment on a virtual machine I control that I take snapshots of, yeah, fine. Like I can run this, I can run ResetBase, and if there is a problem with the image, in say 6 months, an update causes all manner of problems, and I want to roll back. In my home lab environment, I've taken snapshots of the VM. Whereas if it's bare metal machine in a production environment, or even if it's just your main home desktop where there aren't any backups of it, I would very seriously think about whether you want to use ResetBase or not, because as I've said, if you do use it, obviously you'll free up probably an extra 5, 6, 7 gigabytes of data. For that freed up space, you now lose your ability to roll back if there's any problems with a future update. So yeah, definitely think about whether you want to use this or not. But in this instance, this is a VM. I have snapshots. If it bricks itself, I don't mind too much, and it's also good to be able to show this example. So let's just run this command. Again, we're going to see the loading bar as it performs its magic, and I don't know how long this will take, so I'll probably speed this bit up. So far, it's looking quite good.
"15 minutes later."
And there we go. Operation completed successfully. Let's run TreeSize free again. Let's refresh it and see what difference we've made. Okay, so 10.4 gigabytes left. That means we've taken roughly roughly 9 to 10 gigabytes we've freed up in a safe manner. Now remember, we haven't touched a single user directory. We haven't uninstalled any apps. Windows is obviously fully functional, as you can see. And so, yeah, that's a really neat little tool. Let's go back to let's continue this and just finish this job off. So we're going to go back to System, going to go back to Storage. I really want to see if that removing previous versions of Windows. I really want to see if that's that file. I've used like disk cleanup, for example, where we go disk cleanup and click all these. In fact, why don't we just do that? Let's see how much space we can really reclaim. So we're going to do all the standard files. Hit OK. Let it run its course. Awesome. So that's now run. Let's click this. 28.9 gigs. So if we go back here. So what's this? 36 for windows.old. Let's see if this does this. Continue. I'm fairly confident that's what this is, but we'll find out together. Okay, that's now finished. All right. Let's now. It's looking a bit better, isn't it? 208 gigabytes free. And before it was 175, so 25 plus 8 is 30. Yeah, 33. We freed up 33 gigabytes altogether. So let's refresh this again. Yes, it was. Okay, cool. So that's really cool. So that is, now we have WinSxS, which is the Windows components folder. We have that down to 10 gigabytes. And it looks like it's completely removed the windows.old folder. So that's another 30 gigabytes there. So that's absolutely fantastic. Very effective. Again, we haven't gone through and uninstalled anything. Windows is still working, but we've freed up a decent amount of space. We've now, between 30 and 35 gigabytes altogether. So very successful. Post cleanup results are in. We've managed to free up roughly 40 gigabytes of data. That's no small feat. We haven't touched a user file. We haven't uninstalled a program. Windows is still working. And that's a very, very effective way to reduce overhead. And every time I take a backup, every time I take a snapshot or a clone, that's an extra 40 gigabytes of data that's being just taking up space that doesn't need to be. It's input-output operations on that data again that doesn't need to happen. Now, obviously on your own system or my own system, for example, fantastic. I've just freed up 40 gigs. I've reclaimed space, but in a home lab or in an enterprise environment, multiply that out for every single image that you're running. If you're running 10 images on your home lab, or if you're running 100 virtual machines in an enterprise environment, that 40 gigabytes soon multiplies out. And, you know, at the end of the day, that's cost. It's resources cost, it's compute cost, it's the cost of storage. And this is the underlying skill here. It's not just the disk cleanup. It's about approaching it with a sort of forensic mindset where you want to look at system components, you want to use the right tools like DISM, and you apply that to really maximize the reclaimed space you can have, and understanding the downstream effects of that, where you're saving on storage used, you're saving on resources when you're backing up and cloning virtual machines or images or containers or whatever it is that you're working with. And so, yeah, it's an absolutely valuable tool you can use in both at home and in a production environment. If this was useful, drop me a subscribe. I'd love to see if any of you have done something similar on your own systems or in an environment that you work in. I'd love to see what results you've got with using these tools to clean up the storage space. See you at the next one.